Hey everyone, welcome back to my YouTube channel. Today we are solving a problem in which we will check if a binary tree is height balanced or not. Do not worry, I will walk you through it like you are learning for the very first time. So let's get started. First of all, what do we mean by a height balanced binary tree? Let me explain. A binary tree is height balanced if for every node the height of the left and right subtrees differ by no more than 1. Okay, and trees with the left and right heights equal, then it means the binary tree is balanced. But if tree with the height difference greater than 1, that means our binary tree is not balanced. Okay, so let's first of all check the binary tree. So in this binary tree, as we can see that height of node 9 is height 1 because it starts from there only, and the height of node 20 is 2 because it starts from here to here. Like a 15, height of node 15 is 1 and height of node 20 is 2. And like node 3, it has height difference of 1 minus 2 that equal to 1. That means it is balanced and output should be true. And for another example, here you can see left subtree is deeper than right and height difference is greater than 1. That means it is not balanced. So what we will do is that we will return false. Empty tree is always balanced. So we will return the output true. So we will start from brute force approach and we will find out the problem with it. So let's start with the brute force approach. We will write a function to calculate the height of each subtree and check if their difference is greater than 1. So to solve this problem using brute force algorithm, we will first import from typing import optional. Okay, and then we will create a TreeNode class, TreeNode, and it will have def init, and it will call self comma val is equal to 0 and left is equal to none and right will also be none. And what we will do here is that we will define the self dot val is equal to val and self dot right equal to right and self dot left is equal to left. And then coming to class solution, here we have a function called def is balance. But first of all we will calculate the height, so we will define the height, def height of self comma node node node, and then there will be optional and it will be TreeNode. That here we will pass TreeNode inside the optional, and then end, and it will be returning if not node, then it will return 0, otherwise it will return 1 plus. Okay, and it will also return 1 plus max of self dot height of node comma left comma self dot right self dot height and then node dot right. Okay, now coming to balance function, we will check if it is not root, then we will return true, because this is the third example that we discussed. Like if our binary tree is empty, then it will return true, and otherwise we will check left is equal to self dot height of root dot left and right is equal to self dot height and root dot right. Okay, and now we will check if absolute of left minus right is greater than 1, then we will return false. Otherwise we will return self dot is balanced of root dot left and self dot is balanced root dot right. Here we are checking for the left root and right root, and if they are balanced, then it will return true, otherwise it will return false when we have the difference greater than 1. Okay, so now let me try to run it and check if it works or not. Okay, I think I missed this dot, and it should be dot instead of comma. Now I will check it again and check if it runs or not. So as we can see here that our code passes all the test cases and runs also so now we will try to submit it and check how does it performs at the very first go. So as we can see here that our code passes surpasses only 31.83% of users. The function height returns how tall a subtree is, at at each node we get left and right subtree height. Okay, and we will get the we will check if their difference is greater than 1, then we recursively do the same for left and right children. Problem with the brute force approach is that we are recalculating the height of the same subtree many times. That gives us a time complexity of big O of n square in the worst case. So what we can do is that we can try another approach, optimized approach, which we will which will use post order and early exit also. So let me try to optimize this one. We will optimize this using post order traversal, where we can go deep into the left and right children first and then compute height while bubbling them up. Okay, and here is the clever trick. We will return -1 as a signal if any subtree is unbalanced. That way we can stop early and do not need to compute unnecessarily. Okay, so let's try to implement it in our lead code platform. Here we have defined our is balanced check, and we will define another function def check, and that will check the node, and if it's not a node, that means our tree is empty, then we will return 0, and its height will also be 0, and then again we will check for the left, so it will be left of check and then node dot left, and then if left equal to -1, then we will return -1, and then again right equal to check node dot right, and if right equal to -1, then we will return -1, because like this will be this will tell us that it is unbalanced subtree on right, and then again we will check for the absolute difference between left and right, abs of left minus right, and if it is greater than 1, then we will return again -1, otherwise we will return 1 plus max of left comma right, and then again we will return the check of root not equal to -1. So first of all we are traversing the binary in post order. first we are visiting left, and then we are visiting right. Okay, and this lets us compute height from the leaves upward. And if any subtree is unbalanced, we need to stop immediately. That's why we will return -1. And final decision, we if we never return -1, then the tree is balanced, right? And when we talk about complexity of this code, time complexity of this code will be big O of n, and because we are visiting each node exactly once. And space complexity of this code will be big O of h due to recursion stack. H is the height of the tree. So let me try to run that code and check if it works or not. So let me try to run it. As we can see here that our code has passed all the three. As we can see here that our code has passed all the three test cases in our problem, and now we will try to submit it and check how does it performs compared to our brute force algorithm. So as you can see that our original code was only surpassing 31% of users, but this one passes 72% of users. So obviously this one is optimized code. And notice how the function quickly detects imbalance without calculating full heights over and over again. And that's how you can solve the height balanced binary tree problem efficiently in Python. And like this video if it helped you, so do not forget to hit the like button and drop a comment with the next problem you want us to solve. See you in next video. Thank you for watching.